I don't think this one, Jordan, would be on an exam or on your, it won't be on the SAC, because this tan 45 knowledge is not, we don't teach you that. That's a and that would be assumed knowledge of a method student, so don't worry about this one. But this is how you'd work it out. You'd have to go to your calc. I've got down to the two equations which both have y and x, so you can solve them simultaneous on your calculator, where you go menu, whatever, algebra, and solve simultaneous equations. But don't stress about this one. Sorry, with this rule, I forgot to say, that's actually square root of all of that. Sorry. So this question, like the previous, it's good if you draw a floor plan and then a 3D plan or picture of what's going on, and then you can sort of work out, because you sort of need to use both, maybe the floor dimensions with using some of the elevations. So I'll draw them up for you first. Okay, because B is on a bearing of 160, you know that this in here would be 90, so that makes this in here 70 degrees. So what the question's asking is that this distance here is the question, sorry, between A and B. That's the question, so I might call that X. But we have, this is what I just drew there, is like the floor plan or map plan. Now if I draw the 3D plan, okay, so they said that the angle of depression from this add down to A and B. So if I've just drawn them on other sides so I can see. So they said the angle of depression for A is 40 degrees, so you know that's 40 degrees. And for the B, they said the angle of depression is 20. So because angle equals depression equals elevation, we know that's 20. Now if you look along here, this is going from the add along the ground to A, so that you could call that, if I call that, I don't know, I'm just going to call it, I'll call it little a. There you go. We could say that's little a up here. And if I draw like a line from the add to B, and I just call that, I don't know, Z. I might change that A to, I don't know, Y. Okay, so that's Y there, and that's Z there. Now you can see, if I was to find X over here, that I could use the cosine rule. So I could say X equals the square root of Y squared plus Z squared minus 2 times Y times Z times cos, and we know that's 70 degrees. So I could do that, or actually, because this is probably, oh yeah, because we don't know that's a right angle triangle, just looks like it in my diagram. So yeah, we'll definitely be using the cosine rule here to find X. So we need to find Y and Z, and that's when we can use this elevation, because we know that the tau, or whatever it is, the height advertising is 750. So I could essentially do SOHCAHTOA over here and find out what these ones are. So this would be opposite over adjacent. So I could say tan 40 equals 750 over y, and so y is actually 750 divided by tan 40. So you could do that in your calculator, and then you would have an answer for y, which we could put over here, and then I could use this one over here, and I could do the same, but I could say tan 20 degrees equals opposite, which is 750 over z, so therefore z is equal to 750 divided by tan 20. So then I have an answer for z, and I can put that over in here, here, and then I can solve it, and I'll let you do that. Okay, when you find the angles of here, so TAB, if you have a look, that this triangle T there, that's the one. So that's, if I draw that out, got something like that. So I've got TAB, but you can see if all the way up, we go all the way up to here is 10, and then up to that bottom line is 7. that makes this in here 3 degrees. So you know that angles TAB, remember you look at the middle one, that would equal 3 degrees. Now angle ABT, so ABT, so they want this one up here. Okay, so and ATB, and they also want that one up there. Okay, we can actually find this B angle here, or that one there, by, if you have a look, we can see there's a straight line of 180 in there. So if I find out that one there, I could do 180 minus that one, will give you that B one up there. And if you have a look, we've got 90 here, we've got 10 here, so that makes 100. So that makes that star 180. So if it's 180 minus 80, that would equal 100 equals that dot. So we now know that this is 100 degrees in there. So if that's, we've got 100 and a 3, so we've got this one T up there is 77. So you've now found them all. So angle TAB, angle ABT equals, what did we say before? 100. And angle ATB equals 77. So now you've got that. Now they want AB. So if I do this question, I'm just going to fix up my little triangle here. It looks something like that. I know that's 110. They gave me that. I now know that's 77. I know this is 100 and this is 3. So they've asked to use the sine rule. So if I go A, B, C, I'm just labeling it up to get the rules. So I've got little a, and we want AB, so we want C in my diagram. So I'm going to say C over sine C equals little a over sine A. So I would have C is what I'm trying to find, over sine 100 equals 110 over sine 3. I'll leave you to do that. You can do that on the calculator and find CB, the height of the hill. So you just could probably just use, what have you just found? You found A. So you can use this big triangle in here. So to find C, use the big triangle with the T, the C, and the A, and you know that's 10 degrees. And you've just found this from the answer here. So put that in there, and then you could use SOHCAHTOA. So, and you want to find this whole distance over here, which is, over here, which is the opposite of a hypotenuse. So you could use sine and so on. And then whatever your answer is, just minus 110. So BC is actually equal to TC minus 110. And that's how you do it. I'll let you do the workings out, but hopefully that helps. Okay, with this question, although they've given me the north line, I'm going to draw my compass in fully to work out. So I can see that A, bearing of C from A is 35, so they told me that. Now the bearing of B from A is 346. So they're saying all the way around there is that 346. So if we go all the way back to the north line, that'd be 360. So I know that's 14 degrees in there. So now that you know that's 14 degrees, you know the total in here must be those two added together, which is 49 degrees. So find angle ABC, we just did that, and then use the cosine rule to find BC. So if I drew out, just simplified the triangle that we've got, so we've got A, B, C, and we've just saying that's 49 degrees, and we know this is 340 km, and this is 160 km. So if you label this as little b, little a, little c, they want BC. For me, that's little a. We're going to use the cosine rule which is a will equal the square root of b squared plus c squared minus 2bc cos 49. And you've got all those pieces of information, so you can pop them in your calculator and do that. So that one was probably the easiest ones of the ones you've asked.